Hey guys, welcome to yet another video on the summary of chapter 5, which is the moment of a force. Basically, we're talking about turning effects here, and moment of a force consists of two items, two variables, two physical quantities. They are the product of the force F and the perpendicular distance. That's how we find moments here. Okay, so there's a formula here, and because over here, as you can see, we got two main directions. One is if the pivot doesn't move, if a force downwards on the right, it will go in a clockwise direction, whereas if a force upwards on the right, it will go in an anti-clockwise direction. Okay, principal of moments, gonna know what is this? It means the sum of anti-clockwise moments equals the sum of clockwise moment about the same pivot. Okay, what do we mean? Okay, basically in short, that this whole diagram summarizes everything. If you got a couple of forces here, F1 at a distance D1 from the pivot, F2 at a distance D2 from the pivot, and F3 at a distance D3 from the pivot, how you apply principle of moments is that you gotta first determine for each of these forces what kind of moment, what direction does it give you. Okay, so in this case, F1 downwards give me anti-clockwise, F2 also anti-clockwise, and F3 clockwise. Okay, so sum of anti-clockwise moment equals sum of clockwise moments. Since I've got two anti-clockwise moments, I add both of them. The force times distance plus force times distance, F1 times D1 plus F2 times D2 equals to F3, which is the clockwise moment times D3 over here. Okay, next up, center of gravity, gonna know the definition is a point at which the entire weight appears to act, not where the entire weight acts, but it appears to act. Okay, so you can actually use that as an imaginary point. Okay, stability is the ability of a body to return to its original position after being slightly tilted. And two conditions that will improve the stability of a body. First one will be you have to keep a center of gravity as low as possible. The second one, base area as wide as possible, which is why a sports Formula One car is very low, so that it as well as very wide, because it needs to be very stable, especially when turning corners, so it doesn't tilt over. Okay, this thing here. Okay, you just got three cases for stable, unstable, and neutral equilibrium. Okay, you can see for a body here that actually increases. It will to be tilted slightly. A stable equilibrium, the CG will always rise, but for unstable, it will fall. Okay, neutral, it doesn't move at all, right? Okay, so for stable and unstable, you can see the center of gravity for stable will always be inside the base, whereas unstable be outside the base. Base just point here. Okay, so the result of that will be it will cause a stable equilibrium, will cause an anti-clockwise moment back into the original position, whereas for unstable equilibrium, it will cause a clockwise moment toppling it. Okay, neutral equilibrium will just stay where it is. Alright, hope you enjoyed this video on a summary of turning effect of a force.